The first 3D printer that I built, 2011, it was actually made out of 3/4-inch water pipes. This thing was freaking loud, but it somewhat was able to actually print three-dimensional objects. You need to feel this intrinsic motivation. You can call it fire, you can call it eagerness. You need to do that. The capabilities of designing will be unmatched to whatever we have seen in probably the last 100 years. We also need to try now to get manufacturing at least trying to pick up the pace. So we have to build more with less. Probably don't have the people to do that. And we have engineers to innovate at the speed of software.
What are your plans, and also what kind of people do you need to grow your stack now?
I think long-term speaking, we're going somewhere in the direction of a software company.
So today we are at Saeki. We are welcomed here by one of the co-founders, Matthias. Hi, Matthias.
Hey, Yannick.
Thanks for having us here.
Thank you for stopping by.
I'm happy to be back here. I know the place a little bit. Today it's, we'll go through the journey, your journey as a person, and of course the journey of Saeki, which is, we could say, at the beginning. Long journey up front, but let's go step by step. To start, please introduce yourself a bit, your background. What did you study eventually? If you want to start earlier, the relationship to architecture, you will tell us.
Yes.
That's your roots, and then we'll go through the connection with composites and through the tech stack.
Perfect. So thanks again for coming over. I haven't seen you, I think, in a month or two, so it's always nice to see you. As an introduction, my name is Mattias Leschok. I'm one of the co-founders of Saeki. I, at some point in my life, studied architecture. That's already over a decade ago. I never actually worked in an office. I was always very intrigued by, technology, additive manufacturing, robotics, programming, whatever you name it. I was always the geeky one trying to figure that one out. And I was actually just for another presentation, I was revisiting some old slides and some old stuff that I've been doing. And I think the first 3D printer that I built was in 2011. So that was long before you could just go ahead and order, the $200, $300 printer on the internet and everything would just arrive. So the first thing I've built was actually made out of 3/4-inch water pipes. It had, like drawers that would move as axis. This thing was freaking loud, but it somewhat was able to actually print, three-dimensional objects. I started doing this endeavor of building my 3D printer during my architecture studies in Germany, in Karlsruhe. So that's my official background. I'm a trained architect, finished my studies, came to ETH Zurich to do the MAS DFAB program. That's like a postgraduate study program where you learn about robots, about 3D printing, about programming, about computational design. And this is something where, I was really thriving. I was really loving what we were doing every day. It's a lot of, you could also say, crazy things when it comes to scale, when it comes to complexity. Yes. And then after the MIS DFAB program, I started doing a PhD together with Professor Dillenburger at the chair of digital building technologies. That was a journey of 5 years approximately. And during the end of this endeavor, during my PhD, I came across Andrea and Oliver, which are my two co-founders of Saeki. And we started exploring and working together in something that is called the Robotic Fabrication Lab, or for short the RFL at ETH Zurich. So that was the first, playground for us to use robots, to use large-scale 3D printing, and come up with something that was what we believed at that time, our first product at Saeki, which was like a control system for like large-scale extruders.
Maybe we can go back. You said you met your two co-founders. How does that happen? I mean, you just walk around ETH, you meet two nice guys, and you start a company.
I wish it would be that easy.
So how does it at a human level happen. I mean, how you meet people, you work together, you get together along well, and then you start a journey. And then also, beside of that, how is ETH organized in going from, I mean, educating, nurturing these high-tech profiles into going, getting them becoming entrepreneurs, basically, starting a company?
So let's start with the first thing. How do you meet them? I think for us, this was a bit of a coincidence, a lucky one. I was working back then, I said, during my PhD in the RFL. We were trying to understand how to print with robots, polymers on a larger scale. And over a friend of ours, he was recommending, saying, I know this guy, Andrea, super eager, he's very intelligent, he's very eager on going and doing something that's not maybe on the straight trajectory of ETH, and I should just, have a chat with him. And during this period in the RFL, we had the luxury to actually use robots, to have a bit of budget, to start, developing a few items, a few components, and Andrea and I basically started this, building a piece of hardware that allowed us to actually control the extruder, to make the tool and the robot speak to each other. So that somehow magically came over a friend of ours, and then Oliver and Andrea knew each other from the makerspace at ETH. So that was another, I knew Andrea knew Oliver, and then the three of us started to continuing to develop this control system. And that worked actually so well that it's, I think, used until this day. Yeah. And I think in the semester after we built this prototype, we were asked to actually scale it down on a cobot scale. So whatever we were using at the beginning was like this large scale industrial level, where we have these big robots. And then we were asked to scale this unit down on a cobot level. So these systems, I think, are until today actually used for teaching. So getting, your hands dirty to actually 3D print with a robot that is running on an unbranded Saeki microcontroller, actually.
Of course, so it means usually people or companies scale up. So you started with a scale down for teaching purposes.
Yes.
Yeah. And coming back to ETH, obviously, I mean, they offer an enormous amount of possibilities. They have great facilities. I mean, great teachers, professors also.
Yes.
And how is it when you decide to make some scientific topics into a business, into a company? Is there a process to spin it off from the university? And how is the university eventually still bound to Saeki today?
So I think there's no clear, manual on how to go about it. I think that's a very individual case-by-case scenario. I think to become an ETH spin-off, as we are one, as many other ETH spin-offs are, I think there is a clear manual. It's either you have to use a patent that was generated throughout the research at ETH. You're clearly using research that has been published under ETH that you are using. So I think for that bit, getting the stamp, I think that's, there's a very certified process to do that. However, getting a person to, because I mean, you need to feel this intrinsic motivation to do that. Otherwise, I think, none of us would have had a problem to get a desk job, I would just call it. So I think there needs to be some kind of, I just called it intrinsic motivation. You can call it fire, you can call it eagerness, whatever, you need to do that. And then we were just also very lucky with Professor Dillenburger supporting us throughout this very early ideation phase. So we had definitely support from our professor back then, but also as I was doing my PhD at the NCCR DFAB, which is the National Competence Center in Research in Digital Fabrication. That's a 16-year program, which was basically divided into 4 phases. And around the time that we thought about starting Saeki, also the NCCR started its last phase, which is basically taking knowledge and transferring it to industry. So for sure, we also had, guidance and help from ETH, from the NCCR. There's a specific transfer person, that enabled very early on industry contacts, helped us writing grants. So I think these are things that are super, super valuable.
Super nice. And now you start a company, obviously, not only at an office. You need machines, robots, we heard. You need to keep playing with those items. I mean, ETH is at Zurich. It's not easy to find big rooms, big facilities in Zurich. So from the day you start the company, you still have access to ETH facilities up to a certain time? Or do you immediately need to find a location and then get money, bring your machine assets into the room?
I think that's very depending on what your company looks like. Like if you have an AI company that is mainly, uses a few desks, computers, maybe access to the ETH supercomputer, I think this is something that is more easy to gain. Like access just to simple office space, I think is something that can be, not saying it's guaranteed, but it's something that you can have relatively easy access. However, whatever we try to do at Saeki is go big, use these big robots, to manufacture big things. So that was a bit more difficult because we could not just simply take an industrial robot that weighs like a ton and put it in the back of our truck and just bolt it down somewhere. So there was definitely a period, I would say, of 6 to 9 months trying to find a location where we can actually, set foot. So I think it's very much depending on what you're trying to build. And then there are options on where you can go. And I think back then we were, again, lucky coincidence, you might say it. We got in contact with Halter. Halter is a very big real estate company. And they just bought, I think they're called officially towers because they have 15 floors or something, somewhere in the outskirts close to Baden. And there we, came to an arrangement that allowed us to very early on with very limited budget, start our journey of Saeki, buying 2 very old used robots just to kick it off. So there, we had a good run.
So here you are, you have your rooms, your facility, some robots. So the 3 of you are happy, you can play, but on the other side, you have a company.
Yes.
So it's more than playing. There are obviously interests eventually of partners or people supporting you. So on this topic, when did you start to, decide, do you bootstrap, work on projects, earn money, get money from grants? You mentioned you were writing grants. So how much did they support you at the beginning? Or did you very quickly go the VC way, so fundraising, private capital?
I think at the very beginning, we actually, the 3 of us, as we started Saeki, played around with the idea of Saeki during COVID. We used a lot of online platforms that you could, use to get a grasp of what it would mean to actually build a company. And there we started participating in Venture Kick, which, with me, I spent a lot of many years being in academia. So that shifted my perspective quite a bit, understanding what might be necessary outside the laboratory to actually make it work. And we went there through all the phases. I think we just didn't won the last one. So we won 2, phase 1 and 2. And then we came to the finals, but we didn't win. And that gave us a bit of a, capital to kick it off and get Saeki going. And already during that period, for sure, me as a researcher, I was writing grants anyway. So there was, smaller batches of money coming in that allowed us, to purchase whatever it might be, a sensor, a control board, just to keep CapEx actually, not of our own pocket as much as we could, avoid that. And then for sure, we also kicked off the VC route quite early because we knew we needed that money in order to build a team, hire people, and, you know, take a chunk to also make sure we have actual capacity to manufacture something.
Okay, and now you said, okay, you have the three of you, you have this support, and now you need obviously people. At some point, you want obviously to get customers, so you need to identify the markets, work on proof of concept projects. So what were the steps from being the three of you, getting traction on financial support, and then probably shifting your mind from doing everything yourself to where do we need additional resources to make it happen and then grow as a company?
I think that's a bit of a journey. It's like, I think it's actually a good thing that if you are, you know, you just started a company and at some point it crosses your mind like, wait, I shouldn't be doing that right now. I should actually be, you know, finding a new client, finding, you know, cheaper rent place, whatever it might be, you should do to, you know, strategize around the bit that you are trying to build. At the very beginning, we kicked it off with a hire on a call it founder associate level. That was helping us to keep our backs clean so we could actually, you know, focus on what we are very good at. We also got, as I said earlier, we started producing elements actually right from the get-go. So we also got a few interns that were just, you know, bridging the last 5% of automation, let's call it like this, just for us being able to actually deliver pieces. So I think that is one bit of a question. And then the other one is, yeah, we spent some time at the beginning trying to understand our market needs, where's our USP. But there we were also fortunate enough, specifically during the first 6 to 12 months, to have a lot of inbound interest because we were building up upon research on 3D printed, I just call it tooling for now. I say tooling, I mean formwork for the construction industry. And there, you know, we were lucky. We had the first project in where the robot basically wasn't fully bolted down yet, which had some created some timeline issues, but you know, we managed somehow. Yeah, so I think that's another aspect. I think right from the get-go, as we got venture kick, we moved out, put the first robot down, started looking for VC money, got positive feedback. We immediately tried to find paid jobs because that's the best market validation that you can have at the end of the day. For sure, until today, to a certain percentage, we still do explorations, trying to go one step beyond what we know today. But we only do that with a clear trajectory where we know, okay, there is business behind that. It's not just I'm trying this now because it's cool, because I'm fascinated about it. It's like, if we manage to do this, we can sell X units of insert your new fancy product here. Yes.
And before going to the market part, so now you described obviously venture kick, some VCs. We spoke about ETH, and you are coming from Germany. So you described part of the Swiss ecosystem. So what, from an outside perspective, I mean, now you are an insider, you are here for quite a few years. What is so special in Switzerland?
I think that's a super good question, and I've been thinking about this also. And I think this is probably different layers to it. I think on the one hand side, ETH, probably also EPFL, like these bigger universities, they just allow you to explore anything that goes beyond, the regular schedule that you have at the university. Like the ecosystem that exists within these units is, I think, in my perspective, mind-blowing. I've studied architecture in Karlsruhe, and that looks a bit, probably it looks different now, but when I studied back then, that was like light years behind what I saw at ETH. So I think it's the infrastructure, but it's not only, the hardware that is there. There are also other aspects that, round up this entire profile. So I think this as a, call it incubator, or so I think that is definitely a very strong position. Then I think another aspect that was, relatively easy for us was to just found a company, like start venture kick. All of a sudden, okay, we need a bank account, but we have cash. We can just start and get going. And I think this is one aspect. I think bureaucracy, I think, is limited here. I think everything has its rules and its order, but it's not as sophisticated, one might say, as in Germany. So I think that's another layer, that definitely helps. And a third one, I think, for sure, there are very strong VCs within Switzerland. But even before you get to the point that you say, I need now money, X amount, because I want to build something very big, I think there is this angel community. I think you have, individuals like family offices that, they would be willing to support you or your team at a level that even starts before the big VC money comes in. And that for sure also, lowers your hurdles. Like you can very much more easy, I think, find financing for a good idea. And then once you reach a certain level with this very first injection of money, convincing somebody on a VC level to give you money, I think, that just makes your probability a bit higher.
I mean, so that's also the experience I have, at least at the early stage.
Yeah.
Very dense network of people, companies to support that. We'll see later on in the conversation if it's still true at growth stages and beyond. But now let's go back to tech, because that's why we are here also. So you said you had robots, we heard extruders. Maybe you can speak a bit more about the Matthias. What is coming out of those extruders? And then we will speak about, how you grow your tech stack over time.
Fair point. I think I actually missed that. What are we actually doing at Saeki? So when I talk about robots, I mean industrial robotics, arms, 6-axis. We are using the brand KUKA. Our robots can reach, 3 meters around themselves in a sphere. We have, when I say extruder, I mean a tool head for this robot. This tool head is able to process different polymers. So whatever we have developed internally, the tech stack is polymer extrusion. If we think of the polymer pyramid with polypropylene at the very bottom and PEEK at the very top, in theory, we can extrude all of these. Whatever comes can be in theory extruded. We have our regular print bed size is 2.50 meters by 1.50 meters by, and then it's depending on how big your footprint is, 2 meters, 2.50 meters. So that is what one unit can basically produce in an additive manner. We call these units pots, and we have multiple of these pots downstairs on our shop floor. And so that's basically the AM part that we have right now for large scale. We have also a German Zimmermann CNC machine that allows us to post-process elements that we have 3D printed. And there we have a similar, build volume, a CNC volume, as we have on the AM side. For sure, that is the hardware tech to, add material or subtract material. However, there's more to it, no? Because we started by understanding what do I need to control the robot together with the tool to have good print quality. So there's, a microcontroller, a control board that lets those two communicate. For that, I also need a piece of software to actually make those things communicate. And this was one of the first things that we've developed. And then if we think about scale, bringing in also VC money, it's clear then if we want to, copy paste our factory that we are developing here in Switzerland, we need proprietary tech also in regards to software.
Yeah.
So we are basically developing something that we call the Saeki OS, which allows us to actually tie all the techie stuff that's happening on the shop floor, together with all the sales-related stuff or the commercial efforts that are happening, outside of the shop floor. And, the Saeki OS is basically divided right now in our own ERP system. So we actually know what we have on stock, what is ordered, and we have also our MES system that allows us to actually organize the shop floor. So these were the two things, or the three things we basically started with. No? We have Saeki OS, the hardware in creation of AM processes, and the CNC machine to basically finish our elements. However, the idea is bigger than just those two things that I've described. As long as we are able to integrate a tool, a 3D printing system, a post-processing unit into our Saeki OS system, I think this is where then things get interesting. Because we can, and this is also something that we see, so in progression, at the beginning, we deliver a 3D printed tool to company A. And it's like, okay, we have this on our BOM, but actually it would also be nice if we can have these aluminum elements. And then for sure, the CNC that we have is capable of machining the 3D printed parts that we have, tooling board that we can just buy off the shelf. That's, a super common thing here, or also aluminum elements. So I think we're trying to, diversify, putting Saeki as a solution provider and not as just a 3D printing company. So basically, I'm not sure how much I can share, so I'm being a bit abstract now. But in this trajectory that I was just mentioning earlier, we have now an off-the-shelf 3D printing system that allows us to print super high resolution elements that, just go along with a tooling for company A. So we are trying to integrate more and more systems and more tech into our manufacturing mindset.
It's super interesting because you explained, you started with a robot arm and an extruder. Obviously, you needed some bridges in terms of software to make them communicate together. And that's also part of what you were doing at ETH. Then you did some move downstream. So you added these subtractive capabilities so that instead of just 3D printing, you were able to deliver a part ready to use for customers. Molds you mentioned. And then you moved downstream on the software stack with this OS. And now you say, you have this OS as a central core capability, which is an asset. As you say, if you want to grow, you have to think strategic. And on this OS, now you are telling us you are plugging off the shelf, or you are able to plug other technologies. Mm-hmm. So how would it look like in 10 years? It's like a big factory, many different technologies, and you can provide a lot more solutions to your customers?
I think, at the very beginning, we were dreaming of this lights out factory, Like we basically have a truck just pulling in, delivering either new pallets or new blocks of tooling board, aluminum, whatever. Humanoid comes, just shoves it in, and, we continue producing. At the end of the day, this whole point of digitizing and automating manufacturing now also comes from this notion of we can basically design anything. We can use AI to optimize any component that we can wish for, and give it another 5 years. The capabilities of designing will be basically unmatched to whatever we have seen in probably the last 100 years. But we also need to try now to get manufacturing at least trying to pick up the pace and being able to have this, you can call it one-stop shop, whatever you might be, like advanced manufacturing. You can drop these words, but at the end of the day, it's trying to increase the capabilities to design highly functional, highly performative elements. We all know these big challenges that lie ahead of us on a global scale. Like every gram we save on an airplane is amazing. The lighter and safer we can make cars, the better it is. The more slender I can create the concrete casted slab that I have. If I build it high-rise with 1 kilometer tall, then every kilo I save is an insane CO2 saving. So I think that goes, across all different industries. Enabling, we have all these buzzwords, like enabling, do we have engineers to innovate at the speed of software? I think this is a bit the core mindset behind that.
Mm-hmm. And now we are talking obviously a lot about automation mm-hmm. and connecting the dots, at software level. And still, when I visit factories, there are a lot of people. Mm-hmm. And tell us more about how in the factory mm-hmm. you're also looking into connecting those different stations mm-hmm. or pods. Mm-hmm. Are you working on this? You mentioned humanoids or robots mm-hmm. eventually carrying parts and having these workflows very automated.
Mm-hmm. I think there are different levels to it. I think on the one hand side, if everything within the factory is connected, you can schedule, maintain, and process optimize very nicely. So I think, but that can happen on a computer screen. And I think, I now made this anecdote with the humanoid carrying something. That's maybe the next step. What we're doing right now is, or what we have actually been developing over the last 12 months is additive automation, because this is something we started with, and at the end of the day, one operator, for sure we have an operator downstairs, but that one can in theory run all 4 robots from one iPad. He doesn't need to be next to the robot. We have cameras capturing exactly the the footprint of the area that we are going to print on. So I think the tech should allow a trained operator to just be efficient.
Okay, now super interesting. And now let's move to the markets, because mm-hmm. you mentioned you were lucky at the beginning to already have some traction. Mm-hmm. Obviously, on the construction world, you have some affinities, and eventually it's also an early adopter, but you can tell us more about that. So which markets are you currently delivering, mm-hmm. and where do you see more traction mm-hmm. and more openness also to adopt these new technologies?
Mm-hmm. I think right now we have 3 strong pillars and a 4th one that we are trying to get into. So we said formwork for concrete, so we have construction for sure as one of our focal points. We have automotive and motorsport. We can now discuss if these are 2. Let's just put them under one umbrella for now. We have aerospace and defense, and these are basically the 3 ones where we see the most traction. I think traction is also now specifically for motorsport and construction. These are seasonal. We see right now during the winter, construction is for sure always dying down, whereas we also know that it's Formula 1 season now. So that's one gives, the other takes again. So, but these 3 are definitely the ones that I think we can provide benefits to on different levels, also with different products at the end of the day. But it's those 3 that I see at the core of our customers.
And when you say benefits, those are pretty new systems, technologies. Mm-hmm. What is the benefit compared to incumbent solutions already on the market?
I think that is a question that needs to be answered for a specific vertical. Mm-hmm. No, that's nothing.
Let's take construction.
Construction, we have. Construction is a ginormous market. We know all these McKinsey reports that construction is the second least digitized industry on the planet. It's just insane to think about because it's so big. So for construction, we know, if I look at construction, I know 3/4 nearly of all things that are built by humans are made out of concrete. Then I look at concrete and I know there's a lot of concrete 3D printing startups right now. But what the market currently knows is pour regular concrete into a regular shuttering or regular formwork. Okay, so let's look at formwork now. We know that 1/2 to 3/4 of all the costs associated to a finished concrete element is the labor and the material costs of the formwork. So, okay, if it's 1/2 to 3/4, there's probably some wiggle room to do something with robots now here. And I think, and maybe the next few arguments go across all industries. I mean, we know our workforce is aging. We know that all Germany, Switzerland, we're all looking actually for talented people to actually build something in a sophisticated way. And the same also goes for construction. Like if I have something that is not a standard straight wall or a standard straight slab, things get all of a sudden complicated and complex. And we were speaking to a lot of precasting plants. This is where concrete elements are basically done in factories off-site, not on the construction site. And some of them are saying, okay, look, if this is not just a square, we order milled CNC foam that we have to coat with epoxy somewhere from Romania, because here it's either too expensive or no one is doing it. So, okay, so that's the first warning signal. And so I think, and I think again, there are multiple things coming together. We have to build more with less. There are these whole, allegories where we have to build every year in New York just to accommodate all the new people that are being born, specifically, in Southeast. So we have to build more with less. We probably don't have the people to do that. And then you give, all these architects that actually now start to learn how to use computers, how to use algorithms, how to design with them. They maybe come up with designs that are, not in the rectangular grid that you can use from an off-the-shelf component book. But even in an absolute regular building, I think 20% of it is at least non-standard. You always have edge cases. You never build on a perfect square plot. Maybe if you're in the US, maybe you can, but here it's definitely not a thing. So to wrap it up, I think we can provide benefits on different levels. We can reduce complexity of the complex, because our robot doesn't care about if it's straight, a wavy wall, a doubly curved wall. Our robot couldn't care less. We can reduce manual labor, on-site, off-site, depending on where these things are built. And another thing is, if we talk about non-standard construction, so again, not a straight wall, not a straight ceiling, there's a lot of waste that goes into making of these things, meaning the CO2 footprint, like the waste generation of these elements, because you just, you create something for once and then you toss it basically. Like you create a formwork once, you cast the concrete, and then you're basically done with it. And I think here we can, yes, we use plastics to create our formworks. However, we make sure that wherever we can, and specifically for construction, we can do that very easily. We directly use recycled polymers. And we have this scheme of, we create the formwork, we give it to the company A. Company A is done casting, we get the formwork back, we get it recycled, and we get new, fresh recycled material. So I think that's another thing that seems to be very important for also construction customers.
So you mentioned obviously innovation being key in bringing new products, new solutions to the markets. Now you mentioned a very interesting point, because you're basically producing a part with materials, in this case thermoplastics. They are delivered to your customer, and obviously in construction that's really true. At the end of the construction, what do you do with these parts? In this case, you take them back. So we go into circularity. But to anchor innovation, you need also sustainable business models. How does it work? Do the customer actually pay for the material, or are you discounting the material and just selling the service?
I mean, it's a bit depending on how far you want to spin it, because at the end of the day, if you think about it, we're just lending them plastic granulates. We reshape them. So we're basically having a renting business of 3D printable plastics. But how does this work practically? We are trying to create a lock-in effect. I think there's no sugar coating here, no? by giving on the used material, you will get a discount for the next order. So trying to, create, we are in a VC game here, trying to create a recurring buying behavior.
So now back to the company growth. So now you grew substantially from a tech robotic company. Do you consider yourself still a robotic company, a software company, because the OS is so essential? And how can you, I mean, we are still speaking about people, obviously. So I assume you grew now from 3 to X. Happy to know how much you grew and what are your plans, and also what kind of people do you need to grow your stack now?
Good question. I think fair point. I think that's something that can be discussed at length. I think we grew now from 3 founders. We are currently 15 people. We have actually 2 new people starting on Monday. So we are bumping up the software side of things. We are okay with the manufacturing capabilities that we have on the shop floor right now. And I mean, we are definitely not a robotics company. We are also not going to sell a 3D printing system to somebody. This as you pivot as a startup, when we didn't know what we were doing, this was one trajectory. But for sure, I would not consider ourselves like a classic robotic company. I mean, there are robotic companies out there, startups, anybotics. They're building a machine that is, their asset that is going to be used by humans. Here it's a bit about, I think we will see how the next months or years develop. I think software is the key to scale what we have. I think that also, at the beginning I said we build our own extruders, like these things that melt the plastic and allow us to print. But that was more of a necessity than it was, our extruders are very good, but there are also other very good, extruders out there. So I think new tech or this large scale AM has commoditized over the last, I would say, 4 to 6 years. Now I think you can buy them really off the shelf and they actually do work. When we started Saeki, I can tell you this was not the case. And so, I think it's more about expanding the capabilities, interconnecting those things. And those things, I mean now shop floor items. And so therefore, I think long-term speaking, we're going somewhere in the direction of a software company.
And in terms of people, I mean, obviously you are handling Matthias, robots, the entire chain on the hardware side. You are ramping up on software. How do you make sure that you can attract the right people? I mean, is it helpful to be in Switzerland? Actually, you say, okay, software engineers I can get everywhere in the world, they work together remotely. How do you handle this flexibility, also bringing people together on a mission, building something new, a new company, while making sure that you get the best people and not only the one who want to come to Zurich or wherever in Switzerland?
Also another good question. And I think, yes, you can get very good people in Switzerland, specifically also in Zurich. I mean, very good universities also around it, spit out every year these very good, very well-trained students. But on the other hand, I think there's the struggle as a, ambitious young startup. Like we can't compete with the salary and the bonuses that you get at Google, Meta, or you name it. So, we are for sure, that's a struggle that we have. And I think that's a struggle that every young startup has within Switzerland. And for sure also all these giga companies can, afford an office directly in central Zurich or directly at the main station. So commute is, limited as little as possible. Whereas here, we're happy that we're still in the canton of Zurich. But, it takes also a few minutes to get here. So that is for sure one thing that, we have to find strategies to accommodate the needs of, also young talents that, maybe are willing to take a bit of a pay cut, but make more of an impact here. And for sure, we have remote software people as well. But here, it's also clear to us, you gotta, create a team. You need to create a bond between these people. They also need to really understand what we are doing on the shop floor, because otherwise, there might be something that is not coded in the right way or not understood in the meaning that we mean it. And therefore, a little tool that we have to create this bond, to make sure everybody is online, is this kind of an on-site that we do from time to time. So it doesn't matter if you work in the UK or in Romania or in France. I think once a quarter, every half a year, we all meet up here. We have enough office space to do such things. And these are our team building events where we make sure that it doesn't matter where you work, if you, do often home office, whatever it might be, to get everybody at the same table.
Now, speaking about people and markets, how is the customer journey basically? Are you rather hunting new customers? You mentioned that at least at the beginning, you had actually people coming to you. I mean, that's always a dream situation. You just need to then deliver. So how do you handle this commercial traction, inbound, outbounds? And what is a typical customer journey in terms of timeline?
I think I don't think we have the typical customer. I think we have, again, we spoke earlier mainly about construction. Happy to also elaborate a bit more on the others. I think at the very beginning, I said we were lucky at the beginning when you kicked off Saeki, that we have a lot of inbound requests that with one robot, we were barely able to handle. However, the commercial efforts that were very low at this point in time didn't match the increased capacity that we actually have right now. So specifically last year, we were ramping up our sales efforts. We also introduced, I think 12 to 18 months ago, our first CRM system. So, we started to be strategic about who do we reach out to, how do we even categorize a client, a sector, and, which 3 to 4 points need to be, ticked off before we even approach somebody. And I think there we also had our ups and downs. It's, I think, part of starting a business. But now we see an increased interest again and also an increased inbound, which I think is always very good to see if people come back requesting a second offer, a second pound. You know that the first thing that you have done, you didn't completely mess up. And I think we have, very different journeys here. We got in contact, and just make an example now with Halter in Integral. Halter I mentioned earlier already. Integral is like a company that does a lot of interior development, furnishing and interior architecture design. And there we had a quick turnaround of a project, I think within 8 weeks from first meeting, follow-up meeting. We designed like a little computational design tool for interior elements, a staircase and whatever not. And, the deadline was clear and we met it. I think we had 4 weeks to produce elements for an entire floor. And that was a super quick turnaround. We have construction projects that we won last summer, and constructions might be delayed. And now it's end of January, and we still don't have the final CAD files to actually produce elements. And then we have, I need to think what was the quote we have from a motorsport company. We have requests that we need to fulfill offer needs to be out within 12 hours, and the part needs to be done between 48 and 72 hours. And, it's this level of insanity that we can manage. But I think the customer journey can be very different. I think one journey that we see specifically with bigger companies is getting on supplier lists is something that specifically at the beginning was difficult with a young company, little track record, like this is a bit more, you have to chew through that. I think right now we see this rather as a smooth process. But again, for a multinational corporate, 3 months getting on a supplier list is like no problem. And for us as a startup, it's like, okay, that's a quarter of our runway. Like how do we, I think here we still think in very different timescales than these very big players that we are collaborating with.
And now as Saeki, as an organization, what is or what are the main challenges currently? And eventually you can conclude on giving us basically an overview of the next few months, maybe 26 and beyond. What are the big milestones, being it financially and also hitting some markets?
I think right now, operational speaking, trying to get the people that we have and people that will start now quickly to the point that they can work independently. I think that is something that we have seen is something that takes time. It takes at the beginning also a lot of input from our end, from the management side of things, making sure that people understand the mission, people understand how to go about their job. I mean, that sounds as maybe a bit cliche, but at the end of the day, we are not this giant conglomerate where every process is very well defined. And first you fill out this form, you upload this. For us, it's a bit, taking responsibility, critical thinking. I think these are things that we gotta make sure that's first of all very important when you hire, but also it's something that you need to instill in the, first 6 to 8 weeks to the people coming in new, and making sure that things run as independent as possible. Then I think milestones for the next months. I think there's for sure a financial one where we start to look for a new financing round. So for now we closed pre-seed and a seed round, and currently we are in preparation, already dipped our toes into a Series A discussion with different VCs. So that is for sure something to look out for. And then I think it's a bit a pity because I cannot speak about these some of these very cool projects that we are currently doing. But I think, and that maybe goes also in the whole discussion of, the commercial aspect of it, the VC aspect of it, like how do we find in this lights out factory scheme that is on our mind, we can produce anything for anybody. How can we find rinse and repeat and actually make sure that we have our recurring and steady income? And I think currently, hopefully there will be in 4 to 6 months some posts about this. I cannot speak about this right now, but we are in discussions with bigger companies that see very specific products that we offer or capabilities that we have for you could call them larger production runs for like constant supply of elements. And I think that is something that we have to be stealth about it right now, but this is something that I can see making a very big impact within the next 4 to 6 months.
Okay, so that's short term, but already bold goals. And of course, we are looking forward to see that through press releases or communication. And at this point, thank you very much for opening the doors of Saeki, sharing so many insights, amazing journey, and still a long way to go. So we wish you all the best and happy to see you soon. Thank you.
Thanks.